Hello everyone, and this is Mahesh. I am lecturer in chemistry. And in today's class, we shall discuss about phase equilibrium. So, what is meant by a phase? A homogeneous and physically distinct part of a system that can be separated by a definite boundary. It is known as phase. Here, what is meant by homogeneous? Homogeneous is nothing but when a mixture of gases or mixture of solution takes place, an uniform layer will be formed. If you consider two non-miscible liquids or immiscible liquids, a heterogeneous layer will be formed. That means a whole uniform layer will not be formed, that is, a single layer will not be formed. Instead of that, double layers will be formed, and we call it as heterogeneous. In our topic, we shall move on, or we can stick on to this homogeneous system. So, otherwise, we can also define phase as a uniform part of a system which is in an equilibrium. It is also known as phase. So, phase, for a phase we have few examples. That is, for one phase system we have oxygen as a best example, along with C6H6, that is benzene, and water. We shall discuss specifically about this water in a one component system, and we shall discuss more in the examples also. And a mixture of gases, that is a homogeneous mixture, oxygen and nitrogen, and miscible liquids, that means when you mix ethanol and water, both will form a single layer, and CHCl3, that is chloroform and water, if we add these two, a non-miscible liquid, that means a heterogeneous layer will be formed, or otherwise we can call it as two layers will be formed when you mix chloroform with water. And finally, NaCl solution, that means aqueous NaCl, uniform, which is a uniform solution. And specifically, if you consider water, because according to our topic, we have water component system, that is under a one component system. So, considering water, how you can define phase in a one component system, that is under water. So, if you consider water in a closed beaker, what happens here? P will be equals to 1. Why? That means neither you heat it, or that means you are not applying any temperature. If you apply a temperature, the liquid, it won't be converted into vapor, as because it is a closed beaker. So you will get only one phase, that is liquid phase. And water in an open beaker, considering the same water in an open beaker, you get two phases. That is, one is liquid and another one is vapor, because as it is a open beaker or an open vessel, and here ice in an open vessel. So here an ice in an open vessel, what happens? If you consider ice in an open vessel, you will get three phases. P is equals to 3, because here the solid ice and it converts into liquid and then it evaporates. So here you can see water in a closed beaker, you can see only one phase, that is solid phase. Water in an open beaker, you can see two phases, that is liquid and vapor. And ice in an open vessel, you can see three phases, that is solid, liquid and then gases. You can see three phases here, two phases here and one phase here. So phase, for a phase we can consider solid, liquid and then vapor. All these three constitutes a phase. And then coming on to component. How you can define a component? A minimum number of independent chemical constituents needed by means of which the composition of each phase can be expressed by an expression. Or otherwise, we can also define it as the physical and chemical properties remains same throughout the reactions. It is also called as component. Normally, we have two components. Two types of component systems. That is one component system and another one is two component system. As I mentioned earlier, one component system, we have best example, that is water system and as well as sulfur system. And for a two component system, we have lead silver system and potassium iodide water system. So we shall discuss all these four in the next classes or in the next videos. Today we shall discuss only about the introductory part of phase equilibrium. And considering the same example, that is water as a best example, how you can define component? Remember, for a component, how many components we are using in water? We are using only one component, that is water. Water is a component. So here the same for water in a closed beaker. Here you get only one component, here you get only one, and here also you get only one component because the phase changes but not the components. The component is water. And then degree of freedom. What is meant by degree of freedom? Minimum number of independent variables such as temperature, pressure, composition that need to be mentioned in order to define the system completely. It means a minimum number of independent variables. What are those number of independent variables? They are temperature, pressure, composition. They need to be mentioned compulsory in order to define a system. Without this, that means without this temperature, pressure, composition, that is independent variables, the system will be invariant. You cannot define a system. And this degree of freedom, it is denoted by F is equals to C minus P plus 2. This is known as Gibbs phase rule. That is, remember, this Gibbs phase rule is for a one component system. F is equals to C minus P plus 2. That is only for water system and sulfur system, but not for two component systems. Because for a two component system, you will get F is equals to C minus P plus 1, which we shall discuss in the next video. So F is equals to C minus P plus 2, where F stands for degree of freedom and P stands for phase and C stands for component. As we have mentioned, this is known as Gibbs phase rule. How you can define Gibbs phase rule? For a Gibbs phase rule, simply you can define it as a relation between component and a phase which are in a equilibrium. That means degree of freedom is related to component as well as with a phase. This is given by a scientist named as Gibbs. So we call it as a Gibbs phase rule. And here I have written F is equals to 1, F is equals to 2, F is equals to 0. If F is equals to 1, then the system is univariant. If F is equals to 2, then the system is bivariant. And if F is equals to 0, then the system is invariant. So how you get F is equals to 1? What is this F is equals to 1, F is equals to 2 and F is equals to 0? Considering the same example, that is water in a closed beaker. Here P is equals to 1 and C is equals to 1. It means P is equals to 1 and C is equals to 1 for water in a closed beaker. If you want to calculate the degree of freedom, you need to use this formula, that is F is equals to C minus P plus 2. That is F is equals to 1 minus 1 plus 2. So you will get F is equals to 2, where we call it as bivariant system. If you get F is equals to 2, it is bivariant system. So how you can define this is water in a closed beaker. Always it is a bivariant. And when it is bivariant, P is equals to 1 and C is equals to 1. And what do this F is equals to 2? What is this 2 remains? This, it defines about the temperature and pressure. That means in order to get F is equals to, if you get F is equals to 2, that means both temperature and pressure are needed. Always remember always remember that composition is need not to be mentioned for a one component system. We will only mention the temperature and pressure. And so here for a water closed beaker, you got F is equals to 2, that is a bivariant system. That means both temperature as well as pressure compulsory, we need to mention that. And water in an open beaker, as we have well known that P is equals to 2 and C is equals to 1. If you calculate degree of freedom for that, P is equals to 2 and C is equals to 1. 1 minus 2 plus 2, you will get 1, which is a univariant system. That means F is equals to 1, which gives you information about either temperature or pressure need to be mentioned. If you mention temperature, there is no need of pressure, and if you mention pressure, there is no need of temperature. And for ice in an open vessel, P is equals to 3 and C is equals to 1. That means you will get F is equals to 1 minus 3 plus 2. So you get 3 minus 3, that is equals to 0. That means F is equals to 0, which is an invariant system. Invariant. Why we are calling it as an invariant system? Because as we have mentioned, here in F is equals to 0, there is no need to mention about temperature nor pressure. Remember, F is equals to 1, either temperature and pressure should be mentioned. And if F is equals to 2, both temperature and pressure should be mentioned. If F is equals to 0, neither temperature nor pressure need to be mentioned. So, this is about the introductory part of phase equilibrium. In the next class, we shall discuss briefly about the water system. And later in upcoming classes, we shall discuss about sulfur system, lead silver system, potassium iodide and water system. Until then, this is Mahesh signing off. And before I sign off, do like, share, comment and subscribe to Chemistry Concepts.